Hello and welcome back to our webinar about IIoT and what you can do with KEB NOAA, the next open automation platform. You have watched videos, hopefully, about IIoT in general and an example how we employ it at KEB with our high bay storage system. And then you have seen what we can do with NOAA, the next open automation platform, concrete. And Daniel has shown you in the last video this setup and how to transfer data for condition monitoring into the cloud. I'm Johannes and welcome back. I will tell you how we can create an HMI with Helio easily and quickly. So about the setup, we have the motor, as seen before, controlled by a drive, and our C6 Compact 3 as the general controller and edge device. And we have added to the mix now a C6 X1 panel, web panel, where Helio runs and where I will log in shortly. First things first, we're here back in CombiVis. So now you should see the screencast. And I've selected the gateway on the Compact 3 and the control, Codesys control on the Compact 3, and I'm connecting right now, which will take us a second and give us the same program that you have seen with Daniel before. We have the same variables, which is the motor control from the KEB library for the single axis control, and I'm starting it now, and we're on run, so we're set to go to program this with Helio for an HMI. Switching over to Helio, now you should see the empty, very greeting screen of Helio as you see it on this small panel here. The only difference is I'm not logged in here as a Helio and HMI developer, but on the screen I am logged in and have the option to create new projects, to import projects. And what I'm going to do now is create an empty HMI and show you from scratch how to access that single axis control variables from the PLC program you have seen right now. Showtime! So here we have the empty Helio HMI template, which will just give you an introductory text and an image on a easy parameter page. I will add a new page from the page types here, which is the dashboard, and you will see me typing to use that filter to get down to the relevant options that I'm looking for. So I create now a dashboard page where we will place the following controls. We have two slots here, the widgets and the footer. I will not use the footer, but I will place an empty widget here. And on this widget, I'm gonna place a gauge. And I will select this one here. And you see we get an informative message that there is no value connected yet. And we don't have any limits here. This is a filter predefined. I will close this one since we don't have any data to work with yet. Switching over to the data tab, I will have to create a connection to the PLC. And this time it is a KEB connection, which means we connect to Codesys. And I already will increase the default sampling interval to be a little bit quicker. The test was successful. I create the connection, and you see the connection shows up here. And we see we have the Codesys communication service and can open it to the single axis control that we created for this webinar with the PLC program for the motor control and all the variables here. And when we have fetched all the values, as of now, you see we already get live values since the actual velocity is blinking a little bit. To get all of these values that live now on the PLC over into Helio and have them available for HMI construction, I drag and drop this node onto the data node here, and I have everything available here. We're going to use a data point here named position something, okay, the actual position, not a set point position. And as you have seen in that orange marker, we can fill in here some metadata, like we work here in degrees, not Celsius, but from 0 to 360 to cover a whole circle. Now we have defined this data point, and we can switch back to here, and I will show you a preview for a tablet with another resolution, so you see a little bit better what is going on here. Now we can connect the data here, and the filter works. We have the limits, we have this position defined, and I can connect this to the gauge, and you already see that we have a value here. This value actually comes from a placeholder, not from the actual PLC, so it's a random value. But we can switch to PLC value, and we see 280 point something degrees here. And when I switch back to the PLC, we will have the same position value somewhere around here, the actual position, and this would be the 283 something that we see here. We are live connected with PLC data to work with. Now there's nothing moving. The program runs, but it is stopped. To control the machine, we add these machine controls, and just to make sure that we have two of them, I will add two here. One is for starting and stopping, and the other is to enable the drive overall. So this is kind of like turning it on or off, and I select the appropriate icon. And to put an action here, I will write a data variable which lives in our available data tree, and this is enable the inverter. And we write a static value and we set it to true, and you see that this button turns enabled. We already can give energy to our motor, turn it on, and you should hear a small click if I press this button. This works. Okay, to the second button, I switch back to Edit, Test. I can operate the HMI, or I can select elements here. We have to connect that second part with another data variable, and this one is named Start, which is here. And now we're going to toggle this to have a start and stop button that should actually do what it says, like starting the motor and stopping it again. What we see now is two things that I want to correct. We have a gauge here, and I want to turn this into a radial control, which covers the full 360 degrees. And on the other hand, we see that these numbers, they were jumping when I turn this to testing again. They were jumping from small numbers to big numbers, and I want to have this a little bit more calmly. I can use the number formatting down here, and I want to have it 3 total and only 1 digit after the comma. So here we go and have this one, and we can start it, and now you see this is much calmer and it covers the whole circle as it works. The default value for the velocity is 360 in, I don't know, 1 second. So this is pretty quick. And stop. And you see in the screencast that we fill this circle here. You will notice that on that X1 panel, there's nothing happening since there is no HMI run yet. I save this one, and we can open this after the screencast when we are done with this one. I was talking about the velocity going around here, and switching back to Edit, I'm going to add another control here, and this will be an input to control the velocity. And we have the actual velocity, and we have the set point velocity that I'm connecting here. And this is set velocity. Typo. So we can already work here with this set point. And if I stop it, we have the 360 default value. We can reduce the speed and see it going round and round a little bit slower. And we can, of course, increase the speed, so it goes around much quicker and we see less happening. I will go for 100, which gives us a nice filling circle, and stop it again. But basically, we are done here with our first HMI. So save this project, and now I'm gonna switch to this X1 panel, and I can have a refresh here. I hope this works. Oh yeah. And now it shows us our freshly created my first HMI project that I can run on the actual panel without logging in, and I see, no, I don't see. I see the first screen from the empty HMI, and what we get is the main navigation since we created a second page. I can switch to that one, and you see here that everything is working, and I can turn on the screen in the IDE, start stop again, and it starts running around in circles. I can increase the velocity from my IDE. So I'm working on the actual HMI here to control my complete setup, my motor, which should now spin quickly. And going back to 100 gives us that nice looking HMI. So stop it again, and that's basically it, how you create an HMI. You can add a lot more stuff since our control here provides everything you need to control a single axis, setting the jerk, setting the acceleration, and so on. And you can easily add it as shown to this HMI. So I'm going to add to this dashboard another control, add element. There is a bar, and I want to have the value bar, and I only have defined limits here on the actual position. So I remove the filter, and I use the velocity. Use the actual velocity to be shown, and I have to set some minimum and maximum values, and I know these run from 0 to 2000. Let's assume this. And I get a value here. Now, the actual velocity is 0 with a few fluctuations. And if I switch back to show what it is, it's now fluctuating around 100 or 360, which would be the default value, 720, which goes up 1000, which goes even higher. And now I'm a little bit scared about that motor going amok. I can have some indication here where I formatted the numbers before. I can define ranges. So everything up to, let's say, 500 is okay, is a good value. And then I'm going to add from 500 to 1000 is already a warning because we're going pretty quick here. And then I'm going to add another one from 1000 upwards. Sorry. Yep, so upwards is critical. Confirming this, you will see we get the values here and the ranges indicated as yellow and red. And since we're not hitting that 1000 exactly, it flips between red and orange. But if we go back to 500, we will see this toggling between green and orange. And if I go down a little bit, we stay well below that 500 limit, most of the time at least, so that we can operate our setting here safely. Stopping things, saving things, and refreshing everything on that X1 panel, which now just refreshes the HMI, shows you that I have updated, in a second, this page. So I will move out of the image and come over here and just start here. So you see we're just all the same on the panel, doing the same stuff as before. We have the on-screen keyboard and set it to 1000 and get into the yellow and red range. Thanks very much for watching our webinar. First part was in general about IIoT, and we showed you an example how we utilize our capabilities here with the high-base storage system. Specifically, we use NOAH, the next open automation platform, to do this. And the second part of the webinar was about NOAH and some of the core features that we explained to you hands-on. Third part, Daniel showed you how to get from this setting or your machine setting data into the cloud for condition monitoring and afterwards optimizing your processes. And I had the pleasure to show you how to build an HMI to operate your machine with Helio, the completely web-based no-code programming environment created by KEB and HMI project. Thanks again for watching. Please do not hesitate to contact us or any salesperson from KEB if you want more information either about NOAH or Helio or both or any of the other parts, maybe a panel. And it was our pleasure to present to you our capabilities. See you again, hear from you, hopefully next time or soon. Bye-bye.